Welcome to our review on radioactivity. First thing we need to remember then is that everything is made up of atoms, and we need to remember the structure of the atom as shown in the diagram there. So if you remember what we've said in our chemistry units already, then we've got the nucleus of our atom there made up of our protons and our neutrons. Protons, remember, have a positive charge, neutrons no charge, and around those in these shells we've got our electrons which have the negative charge. What we may find is that the nucleus of our atom is actually unstable. Now, anytime we've got an unstable nuclei, it's going to break down and we get radioactive decay occurring. And what we then find is, as that radioactive decay occurs, we get one of three types of ionizing radiation being emitted or released. We have three types of ionizing radiation: alpha particles, beta particles, and gamma rays. If we think about the alpha particles first of all, then we can see in that second column of our table that we've got the symbol. So it's the Greek symbol alpha, and then the number 4 and the number 2. So the 4 represents our mass number, the 2 is the atomic number. Now, our alpha particle is a very ionizing particle. It's the most ionizing of all three of these ionizing forms of radiation. And what we find is it's made up of 2 protons and 2 neutrons. So this actually makes it the same as a helium nucleus. And because we've got 2 protons and 2 neutrons, what we find is our alpha particle has a positive charge. The second one, our beta particles, has the symbol beta in the middle there, as you can see. It has a mass of 0 and a charge of -1. Now, the beta particle is also known as a fast moving electron. And because it is an electron, that means that our beta particles have a negative charge. Finally, we have our gamma rays. So we've got a symbol for gamma there. No mass number, no atomic number, because this is purely a high frequency electromagnetic wave. Now, our gamma rays are not very ionizing, but they are the most penetrating. That means they'll travel through the greatest amount of things, and that means it can travel very far. So our alpha particles won't travel very far, they're stopped by a piece of paper, remember, but they're very ionizing. And then the other end of the spectrum, our gamma rays, are not very ionizing, but very penetrating. We have a new word we need to know the definition of, which is activity. So whenever we're referring to the activity of a sample, we're referring to the number of radioactive decays per second. So for example, we might say there are 20,000 decays per second, or the activity is 20,000. So all that tells us is that 20,000 atoms, nuclei, are breaking down each second. As we've already said then, we've got alpha, beta and gamma, which are all ionizing radiations. Now, what that means is that they're going to ionize the atoms of any material they pass through. And remember, by ionize, we mean it's going to become charged. So what we find is atoms are usually neutral, but in the instance that we've got this ionizing radiation passing by, what's going to happen is it's either going to make that atom gain or lose an electron, and that makes it become either positively or negatively charged, therefore making it an ion.